we are coming back for part 2 of our solving irrational equations. Now we're looking at a variable that is inside the radical, and then there's something added to it. So we're looking at this problem, 5 plus the square root of x plus 4 equals 12. I don't want you to square both sides immediately. I want you to isolate the variable first. Because man, squaring both sides, you'll get like a 25 plus 10 root x plus 4 plus an x plus 4. Oh man, that's just messy. So isolate the irrational first. So subtract 5 from both sides. And then you'll get the square root of x plus 4 equals a 7. Now you go ahead and square both sides. Life is not so hard after all. Oh, sweet. X is equal to 53. If I go back in and I check that, 53 plus 4, that gives me 59. That's such a strange... Oh, no, wait. Thank you. This is why I hide my answers under here. I have to subtract 4. Dirt. Ba-doop. I'm glad I checked. It made me realize I was wrong. So the solution is this very strange looking 45, because I went back and checked, and 5 plus the square root of 45 plus 4 is 49. Okay, that'll give me 12. So, review. Isolate the irrational first. How would I approach this cubed rootness? Well, my irrational is already isolated, so that's great, but it's a cube root. Okay, so just cube it. Cube it. Sweet. 11x plus 26 equals 125. 11x equals 99, so x is 9, and awesome. I should check it, being careful of extraneous roots. All right, let's take a gander at this one. Radicals on both sides. Let's just go ahead and square it. Okay, cool. All right, looks like it's going to be a quadratic. I might need to use the product sum technique or the box technique. I'm going to set everything equal to 0, so I'm adding 6x to both sides, and then I'm subtracting 5 from both sides. So I could use the product sum technique, or I could just see if I can fiddle around. I'm looking at the 3 and now at the 4, and I'll get somewhere close to 12. So I'm going to try this. So I'd get 3x squared plus 12x minus 1x minus 4. Okay, cool. So I set each of those equal to 0, so my solutions would be 1/3 and negative 4. Okay. Now, it's really important that I go back and check those. Based on my notes, they're correct, but it's important that you guys would plug this back in and check them. I'm not going to do that on this video, but just so you know, you want to be careful of extraneous roots. All right, here we have the square root of x plus 3. Notice the plus 3 is outside of that radical. Now, okay. My hint here is remember to square all of both sides, and be careful, please, that root x plus 3 squared is not going to be x plus 9. Okay, we're going to have some middle terms. We're going to have x plus 6 root x plus 9. Okay, so if I square both sides, I need to recognize I have a binomial here and do that responsibly. My 2x plus 2 is just going to pop out there. Let me at least just isolate my irrational. So I'm going to subtract 9, and I'm going to subtract an x. Okay, so I subtracted an x, I subtracted a 9. All right, now I'm going to square both sides because I don't feel like dividing by 6 and then squaring both sides. So I'll just say 36x equals, don't forget to properly FOIL this binomial. Okay, so I have a quadratic, set everything equal to 0. So I subtract 36x. All right, I think this is looking hopeful. So x minus 49 and x minus 1. Is that, let me check, is that going to give me the proper middle term? Yes, okay. So 49 and 1 are my solutions. Let me check those though. Let's put in 1 here. The square root of 1 is 1, so on the left side I'd get 4. And then the square root of 2 times 1 is 2, so then I'd have the square root of 2. Of square root of 4, and that's 2. 1 is not working. Okay, well, I guess it just doesn't. Let's now try 49. So the square root of 49 is 7, so 7 plus 3 is 10, so that's going to be the left side. All right, now 2 times 49 is going to give me 98. 98 plus 2 is going to give me 100, so I now have the square root of 100, and yes, that is equal to 10. All right, let me just check that 1 didn't work. So if 1 was right here, I would have the square root of 4. Yeah, that's equal to 2. But if 1 was over here, then I'd have 1 plus 3. That would equal 4. 4 is not equal to 2. Okay, so the only solution is 49, not 1. All right, so you would just write that the solution is 49. 1 is called an extraneous root. All right, here's one final one to practice. I would pause, do these in your notes, and then let's see what happens. This is probably looking annoying, so I'm going to factor out a GCF of 3. Okay, so I'll just divide both sides by 3 and get rid of that 3. So I'm just factoring the x squared minus 8x plus 12. So a minus a 6, x minus a 2. All right, my solutions are 2 and 6. I need to check those. Is the square root of 2 equal to 2 times the square root of 2 minus 6? No. Is the square root of 6 equal to 2 times the square root of 6? Oh no, just 2 times 6 minus 6. No, I think I did something wrong. So let's make sure I FOILed. Okay, so 4x squared minus a 12x minus a 12x. Okay, so minus 24x plus a 36. Oh, I know. Here we go. That, did you see that? That should not be there because it just becomes an x. All right, so we're going to keep this. Sometimes you're going too fast. Good thing I checked. Just modeling. Good math behavior. All right, so minus a 25x. All right. So x squared minus 25x plus 36. So 36, I got 3 and 12. Oh wait, hold on, but it's a 4. X squared. Oh, okay, product sum technique coming at you. All right, 36 times 4 is going to be 144. 144, I need factors of 144 that add up to a negative 25. This is fairly annoying. Well, 12 and 12, that's kind of close, but annoying. 36 and 4. Okay, no. What about, let's see, 8 and 8 goes into 14 once, 8 and 16. Well, I guess I'll just take 144, 12 and 12. Ooh, there's maybe a 9. What about a 9? 9 goes into 14 once, and then 54. There we go. Okay. I was looking at my prime factorization, and I knew that it would be a bunch of 2 3s and then a bunch of 2s. So I wasn't getting at it with my factors of 2, so I was like, let's explore the 3-ness. Okay, so 4x minus 9x minus 16x plus 36. All right, now remember you group them. I'm going to factor out, 4x squared, I'm just going to factor add an x and get a 4x out of minus 9. I'm going to factor out a negative 4, and I should have a 4x minus a 9. Cool, notice these should be the same. So 4x minus 9 and x minus 4. Those are my solutions. So 9/4 and 4 should be my solutions. What? Okay, got it. So let's check though. So 9/4 and 4. So let's go back, because according to my notes, my tricky notes, because we're cheating here, that 9/4 doesn't work. 2 1/4 does not work. So let's plug in 9/4. So the square root of 9/4 would give me 3/2. So is 3/2 the same thing as 2 times 9/4 minus 6? Well, I'd cancel. I'd get 9/2 minus 6. All right, 9/2 minus 6 is going to be a negative number, so that is not working. All right, good thing we checked. So the 9/4 does not work, so you cross that out. That's an extraneous root. What about 4? Well, if the square root of 4, so I'd get 2. Now 2 times 4 is 8, minus 6 gives me 2. Sweet.